Okay, so let's move on and now try to determine the loop guard. Well, what do we know? We know that after the loop is done, the loop invariant is true, and it's not the case that the loop guard is true. And we know that we want to end up in a state where the post condition is true, and we want to pick our loop guard in such a way that that condition implies the post condition. And obviously, inherently what comes into play is something about the relative sizes of the top parts of x and y and x and y. Now, the size of x top and y top is always going to be the same the way we develop our loop. So if we can just reason about the size of x top, then we're okay. So let's have a look. Something has to be true about the size of x top, and remember, we're thinking of x as a column vector or as a matrix, and therefore it's the row dimension of that we're going to extract relative to the size of x. Now, what do we know? If the size of x top is equal to the size of x, since x top is a subvector of x, that means that this is just the vector x. So what that means? That means that this expression is exactly that expression if the size of x top is the size of x. So we want to keep iterating as long as it's not yet the size of x, and therefore it seems like the loop guard should be this right here. Let's think about this. When the size of x top is no longer less than the size of x, it's greater than or equal to that. Implicit in everything that we do is that x top is a subvector of x, so certainly its size cannot be greater than the size of x, and therefore we conclude that when this becomes false, the size of x top is the size of x, and then the size of y top is the same as the size of x top, and then this expression becomes exactly that expression. So what we've done is we've systematically derived what the loop guard is. The loop invariant and the post condition now tell us exactly what that loop guard is. They prescribe what the loop guard should be. So then what we do is we say, oh, now we know what the loop guard is. We can fill that in here, here, and here. We want to stay in our loop while the top part of x is less than the size of x in size. That means that here at the top of the loop we know that that's true. And we know that after we come out of the loop, it's no longer the case that the top part of x is less than in size than the vector x itself.